Hello, people from the future. Welcome to Normalized Nerd. Today, I'm going to talk about multiprocessing and how you can implement multiprocessing in real world cases using Python. Trust me, if you can use multiprocessing at the right place, then it might speed up your code by 5 to 6 times at least. So, yeah, it's a very important concept. If you are new to my channel, then please subscribe to my channel and hit the bell icon because I make videos about machine learning and Python regularly. So without any further ado, let's get started. Okay, first of all, I want to explain the concept of multiprocessing. If you are someone who already know the concept of multiprocessing and only interested in the implementation, then you can skip a couple of minutes. For the better understanding of this concept, I have drawn here two diagrams. On the left hand side, we have got the normal flow of programming, and on the right hand side, we have got the multiprocessing. So let's come to the single processing or the normal way how the program runs. Suppose we have a piece of code and we have divided it into 4 chunks. J1, J2, J3, J4. J represents the job. So you have got 4 jobs happening in the program. So what happens in the traditional single processing is that first the CPU takes care of the job 1, then after the completion of it, it goes to the job 2, then it finishes that, and then to 3, and then to 4. So the total time taken to finish the program is the sum of the times for all the individual jobs. Now imagine these 4 jobs are independent of each other. Now, what do I mean by independent? Well, I mean that the order of the execution does not matter. So it doesn't matter whether we finish job 2 first or job 1 first or job 3 or job 4, okay? So in this scenario, when the jobs are independent and they can get processed parallelly, we can use the concept of multiprocessing. So what happens in the right hand side is we have got 4 processes. So when the program starts execution, we start 4 processes and each process will take care of a different job. So what's the benefit? Well, here we are parallelly processing the 4 jobs. So in case of multiprocessing, the time taken to finish the complete program is the time taken by the largest job. And in our case, job 2 takes the highest time. So that is the time taken by the whole program. So I hope now you understand the concept of multiprocessing. Now, one very common mistake that beginners make is that they think we can only run as many processes in parallel as the number of CPU cores available to us. But that's not true. We can even run multiprocessing on a single core. Well, in that case, we won't get true parallelism. What happens is when one job is doing some IO related work, then the CPU is not being used by the process, right? So at that time, some other process replaces the previous process and does its CPU work. And this is called context switching. Now, another very important thing I need to mention here is that each of the processes gets its separate memory. So there is no shared memory. While in case of multi-threading, they actually access the same memory. So yeah, that's a very important difference between multiprocessing and multi-threading. So I hope this much concept will be enough for you. So let's jump into the coding section. We are gonna start with a very simple program just to demonstrate the difference between multiprocessing and single processing and how the thing actually work. So we're gonna have here 2 different functions. You can think of them as 2 different jobs. The first one is a function called counter1. So it does a very simple thing. It just counts. So here you can see that I am running a for loop for n number of times, and at each step I am increasing the counter. And after the counting is done, it's just printing counter1 done. In the second function, the name is counter2. Now why 2? Because here in the for loop, you can see that I am increasing the step by 2. So this function should get executed in exactly half the time as the first function. So now we have got our two jobs, and first I'm gonna run it sequentially. So here I'm taking a huge number like 2 times 10 to the power 8. Then I am calling the functions counter1 and counter2. Now to see how much time it takes, we have to import the time library, and then before the starting of our program, we are initializing one variable called st, and after the program execution is done, we are also initializing another variable called en. So to see the time taken to finish the two jobs, we can just print the difference between en and st. So let's just run this program. So both of the jobs are done, and the time taken to finish these two jobs is about 13 seconds. And now I'm going to show you how we can use multiprocessing here to speed up our program. So first of all, we need to import a library called Multiprocessing. Now, a very important point for the Windows users like me, that you have to put your multiprocessing code inside the main block. And if you are a Linux user, then you don't need to care about that. So here's our main block. So here we have got two jobs. So ideally, there should be two processes taking care of these two jobs. So here goes our first process. Now to initialize the first process, here's the syntax: multiprocessing.process. And we need to pass two parameters here, target and args. The target will be the function that you are trying to do in this particular process. So in the process P1, I wanna execute the function counter1. And in the arguments, I'm passing the number. Now here, please notice that you have to pass the argument as a tuple. Similarly, we need to initialize another process called P2. Same syntax here, but in this case, the target will be counter2. So after the processes are initialized, we need to start the processes. So that's very simple. P1.start and P2.start. Now after this is done, we need to join them. So that's it. Now we just need the time statements so that we can see how much time our multiprocessing code is taking. Let's run this. Just look at the difference. In the single processing case, it was taking nearly 13 seconds, but in the multiprocessing case, it's taking only about 8.5 seconds. So that's a really good improvement. And moreover, you can see that counter 2 actually finished before counter 1. So that's a proof that our two functions are actually running in parallel. Okay, so that was a very basic program, and here we created the processes by ourselves. But there's a better way that I'm going to show you right now. In this program, we're going to write a prime checking function using multiprocessing. So let's just quickly import the modules that we will need. First, I'm going to write a sequential function that will find if a number is prime or not for all the numbers less than n. So first we are declaring an array, and initially every element in the array is true, and then if we find that some number is not a prime, then we will change it to false. So first of all, we have to run a loop to check every number less than n, and then I am checking if the number is less than 2. If it's less than 2, then obviously it's not a prime. And we need to replace the true with false. And if it is 2, then we don't do anything because 2 is a prime number, right? And if the number is greater than 2, then we need to do this inner loop. And the variable j runs from 2 to the square root of the number. Now, if you didn't know about this method of checking a prime, then let me just quickly explain this. What we are doing here, we are finding if there's a factor less than or equal to the square root of the number. If there is a factor, then it is not prime. So in that case, we are replacing the true value in the array with a false. So that was our check prime function that does the job sequentially. So now we are going to write a check prime function that will be compatible with our multiprocessing code. This check prime multifunction takes num as its input and it checks if this number is prime or not. I'm using the same method of finding primes as the previous function. If a number turns out to be prime, then this function returns the number, comma, true. And if it's not a prime, then it returns number, comma, false. Now, why we are returning the number also? Well, you will understand that when we are going to write our multiprocessing code. So that was the check prime multifunction. Now let's have our main block. Here I'm going to take n as 2 times 10 to the power 6. And to check the primality of every number less than n, our single processing code should take quite a lot of time. Okay, so the single processing code is ready. Now let's do the multiprocessing code. First of all, we need an array that contains all the parameters of our multiprocessing function. Here, our multiprocessing function is check prime multi. That takes a single number. So we need an array containing all the numbers less than n. Then here I am declaring a number of process. So this will tell our computer to initialize 10 processes in parallel. Here comes the most elegant way of writing multiprocessing program in Python. The syntax goes like this. With multiprocessing.pool, and here you need to pass the number of processes you want to run in parallel, then as pool, and then you need to use the pool.map function. And here we need to pass the function that we want to run in parallel. And as the second parameter, we need to pass the array that contains all the arguments to the check prime multi function. And in our case, this is just the array of all the numbers less than n. Please notice that here the results variable stores all the outputs of all the instances of the check prime multi function that is running in parallel. So what pool.map does is it takes the function that we want to parallelize and an iterable that contains all the parameters of the function, and it runs the given function on every item of the iterable. Here the iterable is num array. And after that we need to close our pool, and then we are just printing the results. So let's just run this. Just look at it. The single processing took nearly 12 seconds, whereas the multiprocessing took only about 4 seconds. So that's a huge improvement. And here you can clearly see why I returned the numbers also, because I wanted to show you that it is really working. Here I want to say that the method we just explored with pool.map works only when you want to parallelize one single job. For example, in this case, we wanted to parallelize the check prime multi function. Also notice that here the parameter that is passed to checkPrime multifunction in each instance is different. But what happens when you don't want to change the parameter that is passed to the checkPrime multi? Well, for that and some real-world application of multiprocessing, we need to go to the next example. In this example, we're gonna download a bunch of photos from Pixabay and we are gonna convert it to grayscale. You will notice how multiprocessing makes a big difference in this program. So here you can see I have already imported the libraries, created the list of URLs, and also written a function that does the job serially. So the download function takes the URL list, it loops through every URL, downloads the image and converts it to grayscale and then saves it. Now I'm gonna write the main block, and then to first do the job serially, I'm gonna call the download function. So after running the function, you can see that photos are being downloaded and then converted to grayscale, and they are being saved into the images folder. Now we are going to write the same function using multiprocessing. So here I am calling the function as download multi, which takes only one URL and does the exact same thing. Then we are going to write our multiprocessing code. Just like the previous program, we are using here the pool object, and the number of parallel processes is equal to 10. And then I'm using the pool.map method, inside of which you need to pass the function that you want to parallelize and the list of arguments that will go into the function. Then we need to run the program. And you can see here the multiprocessing took about 3.5 seconds. So just imagine, previously it was around 10 seconds and you are bringing down the time to 3.5 seconds. Now I want to mention something extra. Well, here you can see that the download multi-function takes only one argument, that is the URL, and it is different for every instance of this function. But what happens when you need to pass some extra parameter, but that does not change with the instance of the function? So to demonstrate that, I am adding another parameter in the download multi-function called directory path. Our directory path is images. So I'm replacing this string with the variable directory path. Now to accomplish this task, we need something called partial from function tools. So let's just quickly import that. Then we can write something like this. Inside partial, you need to pass the function that you want to parallelize and the parameters that does not change with the instance of the function. So in this case, the parameter directory path will remain the same for every instance of the function. That's why here I have passed directory path. And outside this, you need to pass the iterable that contains all the parameters that will change with respect to the instance of the download multifunction. And in this case, it is just the URL list. And obviously I need to initialize the folder variable here. And now we can run this program. See, that's working. So that's about it. At this moment, you should have a really good understanding of multiprocessing in Python. And I really hope that you apply the multiprocessing module in your code to make it much more fast. If you enjoyed this video, please share this with your friends and don't forget to subscribe. Stay safe and thanks for watching.